Hi, my name is Matt Bolig. I'm a product marketing director here at Marvell. And today I'll be talking about PAM4 DSPs for global network infrastructure. The emergence of PAM4 optical modules in the data center over the last 4 or 5 years has really been remarkable. When we consider in 2018 that PAM4 was essentially a niche technology at that point. And as we go and look forward a little bit, we're actually going to see a place within the next 2 years where PAM4 will take over as the dominant module revenue generator in the data center. Again, comparing PAM4 versus 25 gig NRZ. And when we look out a couple of years, we're actually looking at a place by 2026 where PAM4 module revenue is going to eclipse $6 billion total. Up until this point, early adopters have been the real story about consuming PAM4 optical modules. And when we talk about early adopters in this context, what we mean is tier 1 data centers. This is going to be like North America. This is going to be a hyperscale. So this is going to be very big companies consuming the majority of what's being shipped today. But as we think about it, those companies are going to keep going on, and they will keep consuming over these next generations. As new switch technologies come out, they'll continue to deploy the newest and the fastest interconnect technologies. At the same time, while they continue to drive that market, there's a second major component that's coming online here, is what we call fast followers. This would be more of the international data center now. And these guys, looking into next year, are going to start to consume a significant amount of share as well. So now you've got 2 geographical localities that are together driving port consumption as we go forward from this point. Shifting now from revenue to port shipments, you can see that again, in 2018, 2019, that there was negligible business in PAM4. But as we move through the early 2020s, the port counts go up into the millions of ports. According to our forecasts, 10% fully of the PAM4 port counts in 2022 will be driven by fast followers. As we draw this percentage into the out years, we can see that again, millions of ports are being consumed by this fast follower market. There's also a second market driver here is new connection types within the data center. More about that in a minute. Now, as we look at yet another type of dynamic that's happening in the data center now, that driving PAM4 is a transition from NRZ to PAM for additional protocols besides Ethernet. So Fiber Channel, PCI Express, and InfiniBand all have protocols today based on PAM4, or will have protocols based on PAM4 within the next couple of years. And when we talk about have any networking conversation, strategic networking conversation these days, there's always a component where we talk about hyperscale and then 5G wireless. So, and the PAM story is no exception here. So actually, PAM4 shipments into mid-haul, backhaul applications started back in early 2019, and there's a new growth dynamic in the market that we'll see starting in 2022 with the initial deployments of 50 gig front haul. again, like the first adopters and the fast followers and the hyperscale, both of these components drive millions of ports. Similarly, we'll see millions of ports pushing into PAM4 front haul ports as we look forward in the next coming years. I alluded to a different component within the network architecture in the previous slide. And what I'm talking about here is really, it's a new opportunity for PAM4 optical connectivity in the data center. And this has to do with IEEE. If you look at 100 gigabits per second, that the effective length of the passive cables or DAC cables of this for at 100 gig are it's less than 1.5 meters. Of course, the spec is 2 meters, but when we consider that you only get about 6 dB of loss on the PCB, there's going to be very few ports that are actually going to facilitate a 2-meter cable, and most likely looking at an effective length of about 1 meter or so. So what that means is 400G based CR4 will not facilitate connectivity to all machines, all endpoints. And we see this, right now, this is about 5 million ports a year, and some of them will have to change to some alternate connectivity. Now, IEEE has recognized this in the 802.3 dB, and as they work to specify 100 gigabit per second multimode, they've got 2 different components here, and this is something new. Up until this point, there'd be one PMD for the standard, usually about 100 meters, but again, IEEE is recognized, and this is with some push from data center operators to go and implement this 50 meter as well. And that's going to be lower cost, lower power, and could potentially be looking at using this sort of a PMD for end of row or middle of row connectivity, effectively changing the top of rack type of architecture we see today. There's some other components that are critical, though, if we're going to consider doing kind of a 100 gigabit per second short reach connectivity, and one of them certainly is the VCSEL. Now at 50 gigabit per second, there really was probably one vendor that was leading and deploying 50 gig VCSELs, and maybe that market not being competitive, the economics were not ever that favorable for large deployment. And we see this changing a little bit at 100 gig, where we'll have at least 2 viable vendors, hopefully more, that will be able to facilitate this market and drive the economics, which are key when we're considering different interconnect technology choices from the top of rack, end of row down. And there's a few listed here. So we talk about connectivity to the machine, meaning it could be NIC or it could be an AI node, but there's lots of different choices here. The copper is in green, and then optical in blue. Of course, we do have DSPs that facilitate that retimed AEC option. So that's certainly a viable choice for many companies. And then for other companies and other operators who are looking for more of a different architecture, right now we've got the 100 gigabit per second multi-mode infrastructure, as I mentioned, coming into place. And this could be implemented with, of course, pluggables or with optical cables. I think it's good just to take a pause here as we consider all of the ecosystem and the different markets that we've been talking about up to this point, just to take a quick refresh on the DSP technology that's enabling these markets. It's very challenging. The hard part about PAM4 is the data eye sampling area is about 20% of that of NRZ. And you've got to concurrently sample the 3 data eyes all at the same time. And so having an adaptive multi-tap FFE DFE with an ADC is actually very critical as we consider that the operating conditions, the environment within the data center won't be totally stable. So there's changes in temperature, voltage, optical parametrics, obviously optics age over time, and being able to have circuits in the DSP that can adapt to those conditions and consistently deliver data with very high performance, low bit error rate is absolutely critical. So the other thing that's something that people have grown to expect from DSP technology is the advanced telemetry that it provides. And this can be used for things like system characterization. We think about like doing like system bit error rate sweeps as pictured on the left there. And then more real-time operational parametrics like as are shown when you have like histograms or eye diagrams. All of these are standard tools within the DSP suite. Looking now at some of the challenges, because if we think about, okay, there's that fundamental core technology in the DSP, but now bringing this to market on a hyperscale has its own kind of set of challenges as we go from just a single unit of technology now to deploying across an entire market. And what we've done here is just put together 4 hypothetical operators, A, B, C, D. Each one is using the same switch. So if we can think about, well, this would be kind of the same switch generation, but in this example, they've all gone and used different types of optics. So operator A is doing multi-mode, operator B is single mode, operator C now, we see a higher density of multi-mode, and then operator D has got a Y cable. So what this means from a DSP perspective is that you really have to have specific products for each one of these optical modules. Now, it's important that you're able to deploy these because now you can go and amortize the high cost of developing the DSP across these different products. But getting to that broad product line is absolutely key. And this is true both for the DSP perspective as well as the module perspective. It makes it very challenging for companies that can't invest to go and play in this market. Of course, the key to the DSP technology is resilience. When we think about deploying a data center with tens to hundreds of thousands of ports, multiple data centers that can scale up to millions, that all of the weaknesses, you will find the worst corner somewhere within within that kind of scale. And so having a significant operating margin is absolutely critical in order to deploy and give the kind of service that's demanded by these operators. And so that's talking a little bit about the kind of base technology, but if we think about now the product development life cycle and taking new products into production, this is another key component of servicing this market. If we consider developing large data centers and the amount of infrastructure that is put in place that then must be connected up, getting all of those new switches and end nodes connected and up and running is absolutely critical when you consider the investment of those, again, thousands and thousands of nodes and interconnect infrastructure. So bringing this technology online quickly is another essential part of servicing this market. And of course, all of this stuff requires a lot of investment, right? We're talking about, just different types of engineering functions for the R&D, but all the other different back end functions to go and to bring that new product out. And then, of course, especially pertinent in 2021 is having the capacity at all of your with all the supply chain partners to deliver those products. Absolutely necessary right now. So for the next couple of slides here, I'd just like to go through a couple of examples showing showing different DSPs servicing different optical applications here. And for this first one, we'll look at just a basic 12.8T switch with 50 gig IO. And this could be FR4, SR8, SR4, or some of the popular nodes there. Definitely not an exhaustive list. But for this particular market, we've got the Polaris family of products. So again, lots of different selections within the Polaris family to service these different applications. And what we see is because all of those choices are available, that the market acceptance for this product's been very strong, and we've shipped millions of ports of Polaris to date. Now, if we consider the back to the market discussion at the beginning here, where we had our early adopters, and now we're looking more at fast followers. So Atlas is now targeted mainly at the fast follower market, who have some different requirements versus those early adopters. And essentially what Atlas does is provide more supply chain agility and flexibility. And if we consider a couple of key dynamics of Atlas, is that it's a bare die product. There's no package here. Leveraging our current technology with DSP, right? We want to go, or with the Polaris DSP, we want to go and make sure that we utilize that proven technology. So it uses that, and again, a more flexible type of implementation, no package, and then also integrated TIAs and laser drivers. So effectively looking at a single monolithic electro-optical solution for 50 gig optical modules. And so that's the Atlas story. Now considering a same 50 gig switch, but with 100 gig IO. And that's the Prima family of products. And this is an 8x50 to 4x100 gig gearbox. Again, this was the first 400 gig gearbox DSP to be deployed at scale. Millions of ports have shipped at this point. Extremely reliable technology that within the industry is set the standard for this application. Here's a special case now of the 400 gig breakout. What you see here is the on the left we've got Alcor, which is our 100 gigabit per second gearbox, and that connects actually to the NRZ. So 6.4T shown here, or 3.2T, and taking those 4x25 gigabit signals and putting them on a single lambda, and then as we go to the right side, those 4 single lambdas going and being transmitted into a Prima gearbox. And the key, of course, for the Prima gearbox is that it needs to support the 100 gig breakout mode. So of course, because those are 4 different 100 gig ports with 4 different clock domains. Another couple of things about Alcor that are important to note that it can facilitate a sub 3.5 watt 100 gig module. And as we think about applications beyond just the breakout, it really is emerging as a viable alternative for CWDM4, when we consider the cost of CWDM4 with quad optics versus Alcor single lambda, just a single optical channel. And then finally, we've got the 800 gig DSP market, and this is currently in early adopter phase, and so a little bit forward looking here, not too much with the 2560, and then more so with the 51T, and with the 25.6T, we've got the 400 gig optics shown, so like an FR4 or DR4, QSFP 112. Probably the form factor there versus an 800 gig DR8, OSFP or QSFP DD. And one interesting thing, as we kind of look forward a couple of years, is we see that, yeah, this is early adopter for the 800 gig, but we probably see those fast followers catching up to this market and start deploying these things in the next 2 to 3 years, whereas at 50 gig, the lag was about 4 to 5 years. So again, as we consider that the cost for bit going down, but the ASPs going up slightly from as we go generationally, this market is growing in a number of different vectors. And to service this market, we've got the Spica retimer here, family of products. We've got it's the first 800 gig retimer. We've got 400 gig options. One thing is true with Spica, with all of these products here today, is we have bare die options. Again, trying to provide more flexibility in the supply chain, and that goes so this option goes across all of these different products. And of course, like all of these products as well, we have a number of different integrated laser driver choices to facilitate many different types of optics. So just to wrap this up, PAM4 is the dominant networking protocol in hyperscale networks. In the coming years, port shipments will go from millions to tens of millions as new markets and applications migrate from NRZ to PAM4. PAM4 DSPs are the preferred optoelectronic solution due to their ability to provide high performance, low power, and advanced telemetry. A full suite of DSPs is required to effectively serve the market. I'd like to thank you for your time and attention today. If you have further questions, please follow up with your local Marvell representative or visit us at marvell.com. Thank you.